Good morning. It's January 22nd, and this is your daily brief in science. Here's everything you need to know. A new experiment in quantum physics pushes the boundary of macroscopic quantum behavior by showing interference with sodium clusters containing thousands of atoms. Researchers in Vienna and Duisburg-Essen demonstrated wave-like behavior for massive particles on a scale never before achieved, using clusters of 5,000 to 10,000 atoms and a giant 7,000-atom sodium object about 8 nanometers across placed in a spatial superposition separated by 133 nanometers. The clusters behave as waves and produce a detectable interference pattern, marking a larger object in a quantum superposition than previous tests. The setup uses a three-grating near-field interferometer with period-precise localization to create a superposition of paths and generate a striped interference pattern that matches quantum theory. The experiment was conducted at cryogenic temperatures around 77 Kelvin in ultra-high vacuum using the MUSSEL apparatus, which employs UV diffraction gratings to observe coherent matter waves from high-mass clusters with short de Broglie wavelengths. The Vienna system also functions as a highly sensitive force sensor, underscoring precision measurement capabilities for isolated nanoparticles. The macroscopicity metric reaches 15.5, roughly 10 times higher than earlier results, indicating a robust test of quantum mechanics on large scales. Key parameters include cluster masses around 100 to 200 kilodaltons in initial scans, de Broglie wavelengths of 10 to 22 femtometers, fringe visibility, grating spacing, and detection via photodepletion and ionization sampling. Nanoparticles are about 8 nanometers in diameter and exceed 170,000 atomic mass units, displaying interference when passing through 3 UV laser gratings. The results align with quantum predictions rather than classical moiré explanations, strengthening evidence for quantum superposition in massive objects. The findings contribute to the broader quantum to classical transition debate, touching on ideas like Schrödinger's cat and macro-realism, and point toward higher mass and alternative material tests. The study outlines a path toward interferometry with even larger masses and materials, with potential enhancements such as a vertical interferometer to further increase macroscopicity. A new study links higher ADHD trait scores at age 10 to greater odds of 2 or more physical health problems by midlife. By age 46, those with high childhood ADHD traits have about a 14% higher risk, with 42% experiencing 2 or more conditions versus 37% in those without high traits. The Regeneron Science Talent Search 2026 has named its top 40 finalists from 35 schools across 15 states, with more than $1.8 million in prizes and a top prize of $250,000 to support the finalists' education. Finalists were selected from 2,600 entrants based on originality, creativity, achievement, and leadership inside and outside the classroom. Regeneron is committing to the program for a decade with $100 million, substantially increasing annual awards and the top prize to accelerate support for top entrants. The event sits in the program's 85-year history, with an emphasis on the March 8 Public Project Exhibition and the March 10 award ceremony. Society for Science, a nonprofit behind science news and STEM outreach, partners with Regeneron to run the competition and emphasize STEM-fueled initiatives and corporate responsibility. Finalist projects span a wide range of disciplines, including neuroscience, environmental science, machine learning, social science, cancer biology, autoimmune disorders, geriatrics, and computational methods. Westchester participants are highlighted with detailed project work, illustrating broad regional engagement in high-level science. Quotes underscore the program's impact on young scientists and Regeneron's mission to nurture scientific leadership, reflecting the STS legacy and the roles of Society for Science and Regeneron. Resources include links to finalists, scholars, notable alumni, and an STS overview, along with media contacts for Society for Science and Regeneron. Official materials provide links to the Regeneron STS finalists, top 300 scholars, and Society for Science pages for more information. This 85th edition continues the tradition of spotlighting exceptional young scientists, with alumni achievements from Nobel laureates to founders of science-driven companies. The collaboration between Society for Science and Regeneron frames the competition as a national stage for original research and scientific leadership. A new study suggests moving the Winter Games earlier by 2 to 3 weeks could nearly double the number of climate-reliable Paralympic locations by 2080, with only a modest drop in Olympic host options. Researchers from the University of Waterloo, the University of Innsbruck, and the University of Toronto analyzed how climate change will impact where winter sports can be held. Keeping global warming below 2 degrees Celsius could expand reliable locations by roughly 24 sites by late century under lower emission scenarios compared with higher emission pathways. A core takeaway is strong involvement of local communities and stakeholders to build shared responsibility and ensure adaptation meets environmental and community needs. Advanced technology, including improved weather prediction and real-time monitoring, can help optimize scheduling and resource management. The researchers advocate combining sustainability, community engagement, and technology to keep events viable as conditions change. Dr. Daniel Scott and Dr. Robert Steiger highlight practical implications for policy, planning, and distributing snowsport events amid warming. Context is provided with Innsbruck 2017, avoiding spread-out bids, Beijing 2022, relying on extensive snowmaking, and Milan Cortina 2026, producing about 2.4 million cubic meters of snow. The study emphasizes environmentally friendly infrastructure and energy-efficient technologies to mitigate climate impacts on event viability. Proposed hosting concepts include regional or multi-country bids, such as Munich with a nearby Austrian city, or a cross-border Quebec-New England arrangement with Montreal, Quebec City, and Vermont or New Hampshire to leverage climate reliability. Snowmaking remains a critical adaptation tool. Without it, only a handful of venues would be reliable by mid-century, but the study argues against ending snowmaking due to fairness and inclusion concerns, advocating for more sustainable practices. Key researchers include Daniel Scott and Robert Steiger, with Madeline Orr as co-author. The work appears in Current Issues in Tourism and informs IOC-IPC planning ahead of future games. A new fossil find in Mille Logia in Ethiopia's Afar region expands where Paranthropus lived and how they adapted to changing environments. The partial jaw and associated teeth, recovered from an older individual and labeled MLP 3000, are analyzed with micro-CT imaging to explore internal morphology. The study, published in Nature 2026 by Alemseged and colleagues, argues that Paranthropus ranged farther north and into broader environments than previously thought. This supports the idea that Paranthropus could shift toward grasses and other resources as grassland habitats expanded, indicating ecological versatility beyond a single woody habitat model. The discovery places Paranthropus within a diverse hominin mix around 2.8 to 2.5 million years ago, alongside Australopithecus and early Homo in the Afar. The lower jawbone and molar crown help affirm the specimen as Paranthropus, likely P. ethiopicus or P. boisei, making it among the oldest Paranthropus remains. Researchers note indications Paranthropus may have used simple stone tools and possessed a highly dexterous hand, suggesting greater tool use capability than previously recognized. The finding prompts reevaluation of hominin biogeography, adaptation, and potential interactions with other lineages, including Homo, in a mosaic view of human evolution. Experts emphasize the complexity of early hominin niches and the need to revise how key differences among early groups are understood. This discovery could reshape understanding of Paranthropus's evolutionary trajectory and its relationship to Homo, highlighting environmental adaptation and broader geographic distribution. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.